Hello everyone, I'm Xiao Gang. Okay, in the last lesson, we introduced a basic diagram of a general engine. In this lesson, we will mainly explain the relationships among modules, plugins, projects, and standalone programs, and how to understand their roles. We won't go into how they are written, just have a general concept for now, because later we will have a dedicated lesson on third-party libraries and how to write third-party plugins including the standard format. In terms of positioning, projects and standalone programs are at the same level. They are actually not that different. The difference is that standalone programs are just small programs designed to accomplish a specific function, while a project is a very large program. A project includes the engines and modules. To understand it, it includes the end modules of Unreal Engine, whereas standalone programs generally do not include the end modules of Unreal Engine because the end modules it has many animation and audio rendering resources. If you put it into a standalone program, it will cause compilation to fail. Okay, so let me give a simple example. For instance, this standalone program of mine is used to copy a file. Then the project might be used to read a file, display it in the game, and then modify the file, and then output it back to the hard drive. So this is one project, right? This is the distinction between a project and a standalone program in terms of their scale. Then the concept of this module and plugin. What is a module? A module is actually the smallest set of code and resource files. That is, it is a set of code file resources. It may contain a lot of code, many images, many resources. Then in Unreal Engine, it is our smallest compilation unit. You can think of it that way. Okay, then a plugin can contain many modules. Then projects and standalone programs. They can all include plugins. That's the situation. So let's first take a quick look at this diagram. This diagram, see it? So the bottom layer is the engine's modules. Then above that are our plugins. They are engine plugins and project plugins. There is a distinction. The important distinction is that your project plugs can reference engine modules, can reference engine plugins, but project plugins. That is, engine components will never use anything from your project. This is completely fine. Okay, so the project can use the engine's modules. It can use the engine's plugins. It can also use the project's plugins. The plugins also contain modules. It's just that the module is written inside the plugin. Right, yes. So the project can use anything. No problem, but note that the game feature project plugin is a very special plugin. That is, the game feature project plugin can reference assets within the project, but it is only allowed to be used in this project. However, our usual project plugins. Look at this shot. It points to the project. Inside the project plugin, it cannot use the project's resources. That is to say, I am a project plugin. Many of my projects use this plugin. So this plugin of mine cannot use the project's resources. We will emphasize this concept later. Okay, let's go back to the very beginning. So here, we have posted the official Unreal Engine documentation's detailed display. You can also take a look. Then, let's wait a moment. We'll continue in the next section or the one after. Let's interpret the document. Okay, let's interpret the document. Let's see if we miss anything. Let's first take our own stuff. Okay, no problem. Let's just let it go. Yeah, then we won't add to your burden. You'll need to understand. Module. It is the compilation and deregistration unit for managing code in Unreal Engine. It aggregates a set of code resources together according to certain rules and specific functionality. Then for external calls, it includes but is not limited to C++ files, text, audio, and images. This is a module, so how does it actually put the code? You can easily understand, right? So how does it actually aggregate text, audio, and images together? We will cover this later in the plugin section. Okay, we can show you. Take a look. Let's first take a look at this module, Sail. When placed in the engine, it is called an engine module. When placed in a project, it is called a project module. When placed in a plugin, it is called a plugin module. Let us bring us here again. We open a project. This is our architecture. Right, then we can know. There's a build here. Faint. We can look at this file. Here, this module. This may not be very clear yet, because it might have omitted something. This is actually the main module of the game. Each name is XGCPP demo. This is a main module of the game. So actually, this folder, let's dig out its path. Okay, so here in this master, this is its module. It has a Build.cs. This is the file describing this module. So this module, everything inside the module folder belongs to this module. Let's give some other examples. Okay, we can take Lyra as an example. Okay, let's take Lyra as an example. Let's keep it simple. Let's look at what we just showed you. This is the result of our rocket launcher and Lyra. We'll talk about it later. For now, just call it Lyra game. This is the game module. Lyra game module. No problem. Okay, then Lyra editor. This is called Lyra editor module, even though it doesn't say module in the name. But actually, let's click on it. This is the lock. We clicked the wrong one. Let's click this one. Take a look. Hey. See? PreDefault. Hey, it's also inside the project. It's a module of the project. It's an editor module. I can tell from the name. Okay, no problem. Then let's take a look at the modules of this plugin. Let's find the plugin. Let's just click on any plugin. Let's not click on a game feature plugin. Don't click on a game feature plugin. It's a special plugin. Let's first talk about general plugins. We are here in this plug call. Well, that's the one. And this is its plugin. This is what it looks like after you open it. This subplugin pluggo describes the entire plugin. The plugin source code is placed here. This is the customized intermediate file. We'll talk about it later. And you'll notice there are two folders here. Actually, these are two modules. You can see this is the game message runtime module. This is the code inside it. Okay, no problem. Similarly, this one is called game safety load. This is the loaders module. So this module called project plugin. It is a module of the project plugin. So where is the engine module? Actually, we can see it here. Here, let's scroll up. There is a UE5. Inside the master is complete. This is the engine plugin. Let's talk about the engine plugin first, because we just talked about plugins. Then click on a report. Let's randomly click on a USD importer. Let's open it. You will find that here, right? And then here, we can look at its path. Look at its path. It is in the engine. Click on importers. Plugin. That means plugins. We are going to open a plugin. Plugin. The plug card. Then plugins. Source has so many folders. You will find that every folder has a Build.cs. This proves they are all modules. You know what I mean, right? These are the resources within his modules. Okay, so this is called an engine plugin. So what is an engine module? Pay attention. This module is a module of the engine plugin. It is not an engine module. It is a module of the engine plugin. The key point is, okay, let's take a look at the engine. The engine's modules are here. Right here. Okay, let's find this location. Let's find the source. It's not a plug. It's not on the plug. It's the source associated with the plug. Then here, you will find many folders. Let's just click on one next. Let's click on this one. This is called an engine module. Let's observe its structure carefully. It's an engine, source, runtime, net, code. This is called an engine module. Inside here are these resources. These are all the resources of this module. Okay, good. We will make these concepts very clear to everyone. To understand what I said, put it into the engine. It becomes an engine module. Put it into a plugin. It becomes a plic module. Put it into a project's plugin. It becomes a project plugin module. Put it into an engine plugin. It becomes an engine plugin module. Then put it into a project. It becomes a project module. Actually, it is divided this way. Okay, no problem. Okay, so for this plugin, we will have a loading timing and a definition of different usage environments. That is, what level is this plugin? When does it load? When should it be used? Right? So how do we understand this? How to understand the loading timing? Let me give a simple example. You definitely need to complete the engine initialization first before you load your project. So can we consider the engine's loading time? Generally, it is above the project level. This makes it easier to understand. Then, when the engine loads between the engines, it will definitely load some of the most basic, some driver, some defined modules first, then next. Based on these most basic modules, It loads step by step. So this is the loading timing. So what is the usage environment? When we are developing, we call it the editor. Under the editor, called editor, this is called development. This is called the development environment. After we package it, after packaging, note that it's after packaging, not in this project, not in the project. Select a shipping build. What is this? I will explain it to you later. That is to say, after packaging, when the player gets this thing, this is called post-packaging. We mainly distinguish between these two usage environments. But in reality, there are many usage environments. However, you should be most clear about these. This is during development, the editor environment. And after packaging, we call it the runtime environment. But there will be many subdivisions. For now, you just need to know these two environments. So then, why do we emphasize the loading timing of modules? Because modules are interdependent. If module A calls module B, then module A is dependent on module B. If module B is not loaded and we try to load A, it will crash. It will crash. So this is about the loading art. We must ensure that the most fundamental dependent modules are loaded first. Okay. At the same time, we prohibit circular dependencies. That is, if A depends on B and B depends on A, then should I load first or put tooth? Well, right. Then I would say, there is no way to load them. I cannot resolve it. It becomes an infinite loop. Therefore, mutual dependency relationships are not allowed. So how do we solve this problem? We will introduce a module C. Then module C loads first. Put the common resources from module A and module B, code resources, image resources, video resources, all into C. This way we completely solve this problem. It's like A and B are no longer related now. So let's take a look here at this loading phase. The definition of this phase loading. Okay, then we find this file. It's actually quite easy to find. I'll just search for it directly. Canary plus C. I've already pasted the location of this file for you. There should be no problem. This is a global search using Canary plus CF. Let's take a look direct. This is the engine's code. It's this file. So he can see, first, you need to load it as early as possible. And then the comment he gives you says, this file, it comes from this bug file. But you need to do it as early as possible. Secondly, our configuration has already been initialized. That is, our configuration has been initialized. This is a relatively early stage. The next is the screen that appears for us. This special is our loading screen. We can take a look at our startup. Let's take a look. This is called special. Okay, good. We won't play this one. Won't break the chain for everyone. Play it here. At what stage? This engine code is not something we should be touching right now. And this is the early splash screen. This is the pre-splash screen. And by default, these few stages, we need to pay attention to. This is before the default. Default, we can translate it for him. You can see for yourself. There should be no problem here. This is before the default phase. This is the default. Usually, most of our modules are loaded at this point. Then this is after the default phase. Then this is after the engine has been fully initialized. And this means do not automatically load this module. Load on demand. This is max reserved for expansion, so you can know the timing of its loading. It is roughly divided into these phases. Okay. Then we have no issues. Let's take a look at this. This is the actual definition of the loading. As for the usage environment, our runtime has already emphasized to you in the editor. Next, please note that our runtime modules are all allowed to be used in most environments. Then, the editor module is not allowed to be used in a packaged build. That is, what does this mean? It means that if, after packaging, the game contains editor code, the packaging will directly spy, or it will crash directly when you call it. So, this is a problem that beginners absolutely must encounter. This is very normal. This problem is very normal. We will later use macros. We will use if editor data only, and other macros to determine whether it is currently in the editor or after packaging. After packaging, we won't execute this code because we simply don't have this resource. So, this is a usage timing issue. Then we can simply take a look at the usage timing code. Hey, let's find it. Because I found here, let's click one. Runtime. Most of them can be loaded except for standalone programs. Then this is loaded everywhere except for standalone programs. Also, these editors run mini line. When this is cleaned, this is basically all support the folded platform. Then this is only after this cookie, that is after baking the game. This is only in the unbaked game. Still developer development tools editor, but there is no command line thing. Then editor will standalone program, or a server, or a client without command line arguments. For Macs, okay, this is the development environment. There are many more, but for now, you only need to know about the editor. Editor and runtime are enough. Okay, so after we look at these two files, you will have a clear understanding of the module definition. Then let's look at the definition of a plugin. A plugin must contain at least one module, but it can have multiple modules. We must define the plugin. Use the environment for loading timing. Okay, no problem. So regarding engine plugins and project plugins, we won't discuss that. Then this game feature plugin. We'll cover it separately later. Actually, you can take a look at the article on game features. It is a special type of project plugin. Just understand it that way for now, because its rules differ from our previous rules. It is a new feature of Unreal Engine 5, so pay attention, that is, plugins. Generally, they are only allowed to reference engine content and are not allowed to reference project content. Of course, plugins can also reference content from other plugins, but similarly, we must follow certain rules, and the modules of your plugin are strictly prohibited from depending on each other. So overall, the idea behind our plugins, basically, engine level, should never use anything from your project. You can just think of it that way and it's fine. Unless you take a project plugin and, following engine specifications, turn it into an engine plugin and place it inside the engine, right? But that would be called an engine plugin. It is not a project plugin, right? Okay, so after understanding the concept of this plugin, let's take a look at the example code. We'll still use this road 2 as the reference. We find our project. This folder hierarchy. We will explain it in detail later, so don't worry. Anyway, we are looking at Lua here, and there are many plugins under this hierarchy, right? We can see this is its definition of modules. It has introduced this many modules here. We mainly look at this UPletka. What is UPletka here? First up, you need to know what UProject is. UProject is this thing. What is it? It is this. Inside, it is a JSON. It describes which engine version this project is for. Its project modules. These are its project modules. What is it? They are its loading timing, loading phase, some external dependencies. It references some plugins. This is what your project does. It manages you. The version of your project has some plugins. We often encounter a plugin that is missing or has issues. We turn it off. False, because you cannot open the editor at this time. You can only manually right-click this thing called your project. Here, open with using this as studio or text to disable the plugin this way. Then your project can restart. Because you can't open the editor right now. So this is you. We talk about a particle. We talk about uplug. It is very similar to you, the actual one. We focus on this module. It proves there is a module here called the runtime module, and its loading phase is this. Okay, no problem. From this plugin, it depends on other plugins. Right, and here are some basic definitions. What file version? Name, developer, contact information, etc. Okay, the parameters in here, we'll discuss that later. Let's first take a look at the documentation. Okay, basically, the plugin. We'll explain it clearly to everyone. Remember this upreg. It contains some information. I should list it out for you later. This level, okay, we want to talk about this project. Is it there? After using the UPlecture, it will be very easy to use upartic. You will know that it should contain a module. And this module is an ordered group module. I may have other modules, some editor modules, or modules with other functions. That means the project can reference this plugin's modules. It can also reference the engine's modules. It can also use the project plugin's modules. But it cannot use the content of game feature, because game feature needs to reference the content of this project. We won't talk about game feature. Yes. Okay, then regardless of the game feature for now, if we continue to look, we can see such a we see one of our simplest projects. This is the simplest project we created, and here, in this place, you can see there is a module. This Build.cs file is very important. We will explain it in detail later. Do you see this here? Public dependency module names include core UObject, engine, input core, enhanced input. This means this module called Yogang KPB demo serves as the main module of the project. Depending on these modules, these are all engine modules. So why is it the main module of the project? Because this is where Formula Game module is implemented. Alright, okay. We'll talk about it at the project level. Let's continue. So a program is a standalone application. What is a standalone application like? It can actually be considered a simplified project. If we want to open a standalone program, we need to have the source code. Then we find our source code here. Our source code is located here. You pick on your engine latest. We find our source code. Okay, then we, in this place, here we open a programs folder. Is this the standalone program? You see, the UBT we used before, right? We used it right here. We mainly look at the blank program. We directly look at the private one. We don't look at this one. This is our standalone program. It implements the application blank program. So this standalone program, this module is called blank program. That is, it is a standalone program. It is very simple. It only has these few files. Nothing else. This is a standalone program, and it also has a Build.cs. See, it references the launch module, empty module, project module. One is public. Let's take a look at this. This is the color scheme. This is not the path for adding access, and this part is a private dependency. This module, what do these mean? We will explain in detail later. Okay, it actually determines this module, where it can read the path from, and which modules it depends on, or how to import this module. That is what these few lines of code do. Okay, let's continue moving forward. Good. We will emphasize it again later. So we've finished discussing the concept above. These four concepts, module, plan, project, programmer, very complicated. And if you look at the official documentation, it's also very complicated, right? So now, let's put it in plain language. Let's summarize again. The engine won't use your project's content. It's that simple, unless you follow the engine specifications. Made it into a plugin for this engine, then uploaded it into the engine. So this part is the engine's content. So this thing of yours is made as part of the engine, can be used by many projects, general projects, and project plugins. You can freely use the engine stuff, no problem. And between two projects, they actually won't reference each other. That is for example, let's take the simplest example. That is Project A and Project B. For example, Wang's Energy and Genshin Impact. They definitely have no relationship with each other. Their engines are also different. So let me put it another way. If we switch to games that use the Unreal Engine, let's just pick one. For example, Fortnite, and this one, which is a humanoid game. These two projects, they have no reference relationship with each other, but they can use a plugin from one project. For example, they both think the communities Inia Lower Park is very useful. They need to use Unreal scripts. They used this plugin, right? The leader is you all say he develops using this graph. We just do it. We just store things as a project plugin. Everyone just imports this plugin and uses it. That's it. And this plugin is not allowed to contain project content. This is very easy to understand. Now this Yogang plugin's content references content from the Geogang project. You can only get Geogang's plugin. You cannot get Geogang's project. Then when you use this plugin, you must use this crash. This is very normal. Therefore, the standard specification for our project plugins is not allowed to reference project content, but the game feature plugin. It can use the project's content. It essentially turns a part of the project into a plugin. Then this feature can be toggled on and off. That's the idea. Of course, this is a bit convoluted. Actually, let's simply give a simple example. Our project team has already built the basic framework. Our 1.0 version is already done. And now we are simultaneously divided into 10 teams. They are 1.1, 1.2, 1.3, 1.4, 1.5, iter 7, iter 8, iter 9, iter 11. The 10 teams are developing 10 pieces of content. All 10 pieces of content are based on our 1.0. developed based on it. Whichever team develops theirs well first, we will launch theirs first. So, for example, Team A, they develop the fastest, then we consider it. We launch theirs first. That becomes version 1.1. And when they develop it as a game feature plugin, right? Then this plugin, if I need it, I enable it, and it can be used. Just these 10 teams, all developed in the form of Gammon Fisher. Whoever finishes development first, I'll just open whoever's work, and then I'll use whoever's work. And the stuff they develop can only be used within our project. It can't be used in other projects because it's all based on our project 1.0. So this is a characteristic of the Gammon Fisher project's plugins. Okay, so finally, let's go back to this diagram. Just a simple illustration. Here, I recommend an article by an expert. Everyone can learn from it. A standard multi-platform plugin. How is it designed and developed? Okay, so specifically, we will conduct an in-depth investigation later. Next, after you listen to this series from me, we will go look at the official documentation. We will check if we have missed anything. Okay, there is still time. So let's look at the Unreal Engine official documentation. This has already been posted in our lecture notes. Marble are our basic building blocks. They encapsulate many functions, such as the editor area, allowing you to use these functions by default. Project blocks each have their own main module. Then, of course, you can also define auxiliary modules under the main module to implement different functionalities. Right? Let me show you a plugin, a pega I wrote for ifLatex. Our ifLatex link has a main module. This main module is exposed for you to use. I put all the exposed interfaces here. Then these other modules, third-party modules, or TTS, STT, or NLP, or the Speric module. You don't need to worry about any of these, because each module has a different function. I have simply placed all the structures together in the main module. This is the architecture. This is its architecture. So the advantage of modules is decoupling. That is, if I want to use water, I use water. Then, reduce compilation time. This is decoupling. I work on one part. That is, develop one part, upload one part. It's not that I have to finish the entire project before you can upload and test. That is the benefit of module decoupling. Then it can be compiled into this compilation unit is even smaller. So I don't need to say that if I change a piece of code, the entire engine will change along with me, right? Why would I change it? Only the code that references my module will change. And here it mentions a rule about including header files. That is, we include whatever header files we need. This avoids including all sorts of strange things. And then this module of ours, like our modularization, we can, of course, turn it on and off as we wish. You just saw the loading timing. I can simply choose not to load it at all. I'll just leave it there. Right, my plug guard doesn't reference it. I won't load the module to save resources. Right, and then this, it has a usage environment specific to a platform, right? And under what circumstances it should be used. So modules are very useful. Very useful. So how do you create a module? Actually, as we just mentioned, this Build.cs file, it defines the module UBT Unreal Build Tool. It will then, based on this Build.cs, link your modules. Generally, within a module, it will create this port and the project's fingerprint chain folder. Then, within our header file distribution and our own source files, we don't want others to see our published header files. Then, in this place, let me check. Then we can define some personalized behaviors. It's perfectly normal if you don't understand now. These are the operations that will be executed. When the module starts and shuts, you can see that we haven't executed any operations here because this module does not have, but many of our third-party modules have operations. Okay, this will be covered later. It will be explained in detail later in the plugin section. Let me explain it to you like this first, so that you, boss, will have an impression after hearing it. Whatever others say. Then, when you encounter problems later, when you encounter issues with plugged-on modules, think about it. Then look at this document and it will be very clear to you. This is the loading timing. We have already explained the phases to you. And this is controlling dependencies. I will explain to you later. That is, which modules this module depends on. Then, if you add a new case file, or after performing operations, you need to refresh the project. The way to refresh is also very simple. This is called refresh project. Regenerate OS files. This is called switch version. Then just open this. This is Lenscam loading the game, right? Yes, okay. So, understand the structure of this module. The module will explain in detail. It is usually the module name. Below a property and proact, it is build, which also defines this file. It is the header file, the CPP file of this module. You need to use a CPP file to describe this module. This header file can be omitted, but I don't like to omit it. I like to bring it out. and this is Build.cs. That is, our target and Build.cs are very important. We will not modify based on this part of the project. To change, do not change the things inside. We always work based on these two files. Let's take a project as an example. Let's take a simple project as an example. Okay, let's find a blank project. We will specify what it compiles into based on this target. It determines how the module is compiled together with the build simulation. You can see, okay, no problem. Let's continue moving forward. Okay, so this means that is this module, the module test module. It depends on the engine's core module. What is the core module? It is actually this module. Let me find it for you. The last runtime call. This is it. It is our core module. That is U++ must use core. If you don't use core, then you won't be able to do it. You know, core, on UG, these, you will find that core over, they actually also depend on core. You will find that every module depends on core. This is completely without any issue. This is the most low-level module. So these do mean these modules, you have used these modules. You need to add them here. If you add robotic, it will be passed in. If it is passed to the module that references it, it will be passed to the third party. If you only add point, then it is a private dependency, meaning it is only used within my own module. Okay, this means public dependency. Put it here in this position. Then other modules won't need to depend on this module anymore because it has been propagated from here. So the meaning of private here is that even after you make it private, if someone else also uses this module, they will have to include it manually. Yes, and this here is a forward declaration. Yes. So you can make it. Most of the time, make it private, but sometimes you are not sure. You often get that link to 0AZ19 error, not found. Just think about it. Is it because the module was not imported, not included? Is it because the header file path is read incorrectly? That's the simple troubleshooting approach. So this place means, yes, this place is actually an architecture when creating a file. We will explain it to you later. Actually, let me summarize this part. Actually, you mean in the project? Let's look directly at the project. Look at the NIY project. The NIY project should be findable. That is the official silly project. In the NIY project, you will find that its header files and source files are placed together. This is completely fine. Okay, and at the same time, to solve this path issue, it has a, take a look, public include paths. This way you can avoid writing such paths, avoid writing this when including header files. This is really annoying. Here, it defaults to starting from this path. To look for this header file, just add one. Look for this header file from the layer game location. You'll notice that when it includes header files, most of them directly start from, take a look, it's not here. Most of them start from this level. It doesn't need to go out. It can start from this level. Just look directly below. That's exactly what it means. Then you will find this original text inside this project. Because no one is including the project's modules, it puts the source files together with the header files. If we were a plugin, we only want our users to include this. We want them to include the header files, but not the source files. So it makes a distinction between public and private. And then the default public, we can all do a wrap, but sometimes we need to solve this annoying header file issue. I would choose to do it this way. This is what I wrote. It should be that we find this. You will find in the public include path and a private include path, I add the module name. That is to allow it to directly include this file. You just write the file name directly, and it will be able to find this file. You don't need to anymore. And then for our own private, in private, I need to include our own header file. Then you can just take this path. Then you will see that in this place of mine, I didn't write any or rate // or any of that nasty stuff, right? I didn't even write the name of the folder I saw. This is a Build.cs technique. Okay, so this is a C++ module. It is implemented through RED. This RED can achieve it. Then we can write this module ourselves. This way we can implement starting and closing the module. This feature. Then if we use modules in the project, you just need to add it to our Build.cs here. And the loading timing control of this module is generally controlled within the project in PyRIA, ILIFC, SIG files. You can see this content And we usually also have whitelist and blacklist designs, etc. Here, its name is this, and its environment, Highland, is runtime. The loading timing is default. This environment as type, the loading timing might not be written here. Okay, then it is not defined. If not defined, it defaults to default. No problem at all. This places some stuff related to this type. We won't click to look at it. And these are some packaging platforms. That is the whitelist, blacklist, additional dependencies, etc. So there's no problem. We'll show everyone. This place means it means some targets are do not include this module. Then the most important thing, to show everyone this one. We can see in UPLA, we wrote this one. It's just that we only have this platform. Within Windows 64 and Android, we only allow it to be packaged. Okay, so this lesson is very solid. We talked for a full 40 minutes, giving everyone this within the basic concepts. This module plugin and project program, how it is done. That's it. Let's stop here for now. We'll talk about this in the next lesson. The hierarchical relationship between the engine and the project.